Assalamualaikum to our lecturer Puan Mahani binti Muhammad Zamri. My name is Muhammad Kamal Azhari bin Muhammad Rashid and my matrix number is 01DPU19F1037 and my group member is Adam bin Sabri. His matrix number is 01DPU19F1001 and another one is Mingwei Yang. His matrix number is 01DPU19F1004. Today we are going to present about topic 5, which is heat exchanger. The introduction for heat exchanger is a system used to transfer heat between two or more fluids. Heat exchanger are used in both cooling and heating processes. The fluid may be separated by a solid wall so that they never mix or they may be in direct contact. Heat exchanger are widely used in air conditioning, petroleum refineries, chemical plants, petrochemical plants, natural gas processing, refrigeration, power plants, and space heating. Secondly, I'm going to talk about principle of heat exchanger. Heat exchanger operate under the same fundamental principles, namely the zeroth. First and second laws of thermodynamics, which describe and dictate the transference or exchange of heat from one fluid to another. The first law of thermodynamics builds upon the zeroth law, establishing internal energy as another property of thermodynamic system and indicating the influence of heat and work on the system internal energy and the surrounding environment's energy. Additionally, the first law essentially states that energy cannot be created or destroyed, only transferred to another thermodynamic system or converted to another form. Thirdly is design characteristic. As stated from the slide before, all heat exchanger operate under the same basic principle. However, these devices can be classified and categorized in several different ways based on their design characteristic. The main characteristic by which heat exchanger can be categorized is by three, which is flow configuration, construction method, and lastly is heat transfer mechanism. There are four flow configuration, which is co-current flow, counter-current flow, cross flow, and hybrid flow. Co-current flow are heat exchanging devices in which the fluid move parallel to and in the same direction as each other. Although this configuration typically result in lower efficiencies than a counter flow arrangement, it also allows for the greatest thermal uniformity across the walls of heat exchanger. And next is counter-current flow, designed such that the flow move anti-parallel to each other within the heat exchanger. The most commonly employed of the flow configuration, a counter arrangement typically exhibit the highest efficiencies as it allows for the greatest amount of heat transference between fluid and consequently the greatest change in temperature. Thirdly is a cross flow. Cross flow heat exchanger fluid flow perpendicularly to one another. The efficiencies of heat exchanger which employ this flow configuration fall between counter-current and co-current heat exchanger. Lastly is hybrid flow. Hybrid flow heat exchanger exhibit combination of counter flow and cross flow arrangement within a single heat exchanger. This type of heat exchanger are typically used to accommodate the limitation of an application such as space, budget costs, temperature, and pressure requirement. After that is construction method. In the previous slide, heat exchanger were categorized based on the type of flow configuration. This slide categorizes them based on their construction. The construction characteristic by which these devices can be classified got three, which is recuperative and regenerative, direct and indirect, static and dynamic.
Type of heat exchanger. Number 1 is double pipe heat exchanger. Number 2 is shell and tube heat exchanger. Number 3 is plate heat exchanger. Number 4 is spiral heat exchanger. Number 5 is plate and shell heat exchanger. First, double pipe heat exchanger. It is also known as concentric tube heat exchanger. Point number 2, in this heat exchanger, the fluid to be cooled or heated passes through the tube. 1. Absorb or release the heat. Advantage for double pipe heat exchanger is cheap for both design and maintenance. The disadvantage, low efficiency and requires large space. For double pipe heat exchanger application, we have 5. For example, pasteurization, digester heating, heat recovery, preheating, and effluent cooling. For heat exchanger number 2, we have shell and tube heat exchanger. First point is, one set of this tube contains the fluid that must be either heated or cooled. The second fluid runs over the tube that are being heated or cooled so that it can either provide the heat or absorb the heat required. Point number 2, they are typically used for high pressure application. For above 30 bar. Shell and tube heat exchanger application have 3. Number 1 is cooling of hydraulic fluid. Number 2 is cooling of engine oil. Number 3 is cool or heat swimming pool water or charged air. Number 3 is plate heat exchanger. It is composed of multiple thin, slightly separated plates that have very large surface areas and fluid flow passes for heat transfer. Point number 2, the plates are often spaced by rubber sealing gaskets, which are cemented into a section around the edge of the plates. Point number 3, the plates can be replaced after getting corroded. Point number 4, if the temperature difference to be acquired is to be increased, then it can be done by adding more plate. For plate heat exchanger application, we have 5. For example, number 1 is water heaters. Number 2 is cooling tower isolation. Number 3 is free cooling. Number 4 is air conditioning. And number 5 is for food industries. Number 4, spiral heat exchanger. Point number 1 is a spiral heat exchanger may refer to helical tube configuration. Point number 2, efficient use of space. Point number 3, they can be easily cleaned. Point number 4, a spiral heat exchanger is a coil tube arrangement with 2 channel coil on one around the another. Spiral heat exchanger application. Point number 1, pasteurization. Point number 2, recuperators. Point number 3, flush treatment. Lastly, plate and shell heat exchanger. Point number 1 is plate and shell heat exchanger are designed for cost-effective heat transfer, performance, and lowest life cycle cost. Point number 2, the unit bolted version allows quick disassembly of the shell for easy access for cleaning, maintenance, repair, or replacement. Point number 3, plate and shell can be configured to meet the need of almost any process requirement in terms of transfer unit pressure drop, design pressure and temperature, as well as piping requirement. Point number 4, the plate and shell heat exchanger is compact with low weight, providing an extremely small footprint.
So thank you my partner Kamal and Adam for explaining. So now I am going to explain about the applications that use in industries of heat exchangers. So there are few types of heat exchangers, like example shell and tube. The industries and applications using are oil refining, preheating, oil cooling, steam generation, boiler blowdown, heat recovery, vapor recovery systems, and industrial paint systems. The other heat exchanger is compact. It has oil cooling, automotive, cryogenic, electronics, cooling, and limited space requirement. So the next type of heat exchanger is plate. It has cryogenic, food processing, chemical processing, and so on. And the other heat exchanger is double pipe and condenser. So these are the examples of application in industries about heat exchanger. So next, I'm going to explain the calculation of heat exchanger. So there is a diagram given and a paragraph is given. So the diagram is giving a few of temperature like inlet and outlet temperature for hot oil and cool oil. So consider as a parallel flow heat exchanger, which is used to cool oil from 70 degree to 40 degree using water available at 30 degree. The outlet temperature of the water is 36 degree. The rate of flow of oil is 1 kg per second. The specific heat of the oil is 2.2 kJ per kilogram Kelvin. The overall heat transfer coefficient is U is equal to 200 volt per meter square Kelvin. So the question is calculate the area of heat exchanger. So the first step, we have to list down the information given from the paragraph. So like mass flow rate is 1 kg per second. The specific heat capacity of oil is 2.2 kilojoule per kilogram Kelvin. So if we change to normal unit, we cut off the kilo, it becomes 2200 joule per kg Kelvin. And the overall heat transfer coefficient U is equal to 200 volt per meter square Kelvin. Okay, once we already write down the information, already list down, so we can start doing the first step. From the figure, we can find that the temperature of hot oil and cold oil is given, so we can find the log mean temperature difference by using the formula delta temperature A minus temperature B divided by ln delta temperature A minus ln delta temperature B. So we substitute the value into the formula, we get 40 minus 4 divide ln 40 minus ln 4. So we get the final answer for log mean temperature difference is 15.6 degrees Celsius. Once we get the log mean temperature difference, so the question asks us to find the area. To find the area, we are going to using the formula Q is equal to U times A times the log mean temperature difference. But we doesn't have Q and the area. So we have to find Q first. For finding Q, we have to use this formula. This Q is equal to m dot times specific heat capacity times delta temperature. So the mass flow rate and the specific heat we get from the information that then we substitute into the formula, that is 1 times 2200 times the delta temperature is, we use the hot oil is 70 degrees Celsius minus 40 degrees Celsius, and we get the final answer is 66,000 watt for the heat. Once we get the heat, we can substitute the heat into the formula to find the area, that is Q is equal to U times A times log mean difference temperature. So the heat is 66,000 is equal to the overall heat transfer coefficient U is equal to 200 times A times 15.6. So we get the answer is 66,000 is equal to 3,120 A. Then we divide the 3,120 to 66,000, we get the final answer of area is 21.15 meters square. So that's all for me for the application and calculation. Thank you.